2004 Volkswagen Jetta with a 1.8T. Customer's complaint is there is no throttle reaction. I believe he towed it here. I certainly hope so, because as I drove the car in from the outside into the bay, the throttle wouldn't react at all. There was nothing there. This is a 1.8T engine, so let's hope there's not very many trouble codes. Okay, I guess I owe it to you viewers to take a look at the car. The car has been lowered. So somebody spent some money to make this car look better. But in the meantime, they've bottomed out the front end here and it's broken. And the radiator and the condenser is held in place by ropes. You can see those white ropes there. And obviously he snagged something and yanked the front end off of it. It's got these nice buttons here. I think that probably holds the front end on when it's there, and probably with rubber bands. Is the intercooler even mounted? Well, it seems relatively solid. I tried opening the hood. That's a standard procedure as we pull into the shop. We pop the hood open. But there is no this right here does nothing. So I spent some time to take this apart, and there's no cable. No cable at all. I can't pull it with pliers. There is no cable there to grab. So I don't know what to do with that. You would think with the front end apart that it'd be easy just to grab the cable here, but for security reasons they do that on purpose. They make it almost impossible to open. So at this point I don't know how to open the hood, but car's dirty, as you can see there, dirt across the windshield, license plate not mounted. It's got some fancy wheels, not really. So I guess the question is this car even worth fixing? It depends on how much the repair costs, of course. But anyway, let's move forward with getting the trouble codes. Okay, there are so many codes, I don't even want to read them all. You can read them. I'll scroll through them, but I want to point out oxygen sensor, bank 1, sensor 2, bank 1, sensor 2, bank 1, sensor 1, bank 1, sensor 2, boost pressure control valve N249. We covered that in another video. Here's the code that I think is relevant. Accelerator position sensor 2, G185. Accelerator position sensor G79. Throttle actuator J338. Fuel injector for cylinder 1. Mass airflow sensor. And oxygen sensor bank 1, sensor 1. So a bunch of oxygen sensor codes, some miscellaneous codes, fuel injector, mass airflow sensor, N249, and our throttle actuator trouble codes. Now let's go into measuring blocks to look at our throttle position. Okay, our throttle related stuff is in the 60s, so from memory it's 62. Now, these are the actual throttle position sensors themselves on the where your right foot goes. These are the angle sensors that sense the position of the throttle body out under the hood. And these two should total approximately 100%. And these two should be the inverse of each other. Obviously that isn't the case. Okay, I'm going to show you what Cortland found. We had a break in the action and I turned Cortland loose on this car to see what he could come up with, and he punched our code number into Rostec, and that's a normal part of our diagnostic procedure because there's a ton of good information on the Rostec wikis. Let me get that code number one more time, 18039. So we punch in 18039 into the Rostec site. And it gives you a bunch of good information, but what I want to point out is that it says accelerator position sensor faults can be caused by issues with the oxygen sensor and its wiring. Please verify this before replacing the ECM. One of the possible causes up here is faulty ECM. Before replacing the ECM or accelerator pedal. Accelerator pedal failure is very rare. That gives us a little bit of direction because we had a ton of oxygen sensor codes. So I guess we need to rack this car up and take a look at the oxygen sensors. I suppose I should show you what this car does as I drive it over on the rack. As you can see there, EPC lights on. There's no check engine light. And that's strange because I know there is a check engine, there is a trouble code in there. Let me restart this. Okay, I turned the car on and there is no check engine light. I need to start paying closer attention to that. No check engine light at all. By the way, that throttle just did that all on its own. I didn't touch the throttle at all. I want to point out, have a light down there so you can see, I'm flooring the pedal and there is no reaction in the RPM of the engine at all. Okay, I'm going to drive this over to the rack. Turn off park brake. Okay, right off the bat, I see some real crappy exhaust work back here. And then up here, I see a performance exhaust system. Oh man, that thing is huge. Look at it. And therein lies the front O2 sensor. And within 6 inches of it lies the rear O2 sensor with no catalytic converter. And right there, back out to the light some. I don't know if you can tell what's transpired there, but that oxygen sensor has dragged the ground. Okay, commentary. Insert commentary here. How dare I be judgmental of my customer's decisions? Someone spent some money on this car. They had it lowered. Awesome decision, I gotta say. Front core support ends up broke. Bumper cover's gone. Radiator's held in place with rope. Awesome decision lowering the car. Okay. Some of this damage here might be due to being lowered also. That's going to rust out. And then here's some real other good decision. Let's make the car faster. Let's put this huge downpipe in there. What is that, 3 inch, 3.5 inch? It's got some beautiful TIG welds on it. That's nice. But the problem with it is they put the oxygen sensor on the bottom facing downwards. And so, if you can see that, let me get the light on there right. That oxygen sensor has dragged the ground. So, we're making some wonderful decisions here. We're lowering the car to where it'll drag the ground, and then we put performance exhaust on there with the oxygen sensor facing downwards. That's genius. Now he gets to spend a whole bunch of money for me to fix the car. And as you can see, there's some beautiful work been done under here also. This wiring harness has been taped up. Wonderful, wonderful type work here and over here. And then there's some butt connectors. Butt connectors are the bane of my existence. Every time I have a tough diagnostic problem, the end result is butt connector with high resistance in it. And then there's some wires spliced together. Not bothered, but no butt connector, no bother. Don't bother to wrap it up with electrical tape. Nothing like that. And then right here, this wire here has some bare exposed wire, and you probably can't see it in the video, but that wire isn't connected at all. The only thing there is insulation. See there, the wire wasn't connected at all. I just broke the insulation to demonstrate to you. So with regards to this oxygen sensor that's dragged the ground, two things. I didn't notice it before, but there is a bare wire right there. There's a heater inside that oxygen sensor, and it has full 12 volts to it. If that full 12 volts gets shorted to the ground, and that ground goes through the computer, what's it going to do to that ground? Right now we need to determine if the throttle pedal's okay. I would worry very much that the computer might be fried. I have run into this exact scenario before where an oxygen sensor got shorted on a Volkswagen. That car wouldn't run at all. The computer was fried on that one. And I don't know if that's the case on this one or not, but we will keep going on it and see what happens. So, crawling around underside of this dash, the first thing I need to point out is that some of these wire colors change color at this connector. This one says gray and blue, but this one over here says gray and white, and it changes colors at the connector to green and white. So the ones that I'm going to be discussing are these colors here. So I'm going to scribble these out so we can ignore that. And that way I don't misspeak or get confused because of that wire color change. But the point is that this gray and white wire comes from the computer with 5 volts on it. And I verified that. That is our power. And then it comes through the potentiometer. And then this is the brown and blue is our signal return. So I'm just going to write signal return here. And this gray and blue is a ground, and it should have 0 volts on it. The problem is our ground has 5 volts on it. And the same thing goes on this. Our yellow and green is our 5 volt reference. It's power. This one is our signal return. And this one should have 0 volts on it. So once again, our song is check power, check ground, check signal return, but our ground is not ground. It has 5 volts on it. So as part of the diagnostic process, we looked at the measuring blocks, and the throttle was not responding when I stuck my foot on it. I could not see any change in the measuring blocks, group 62. So what we did here is we jumped 0 volts here. We put a jumper wire to ground here. So where we actually had 0 volts there. And at that point, we could measure our signal return wires here and here. I'm sorry, here. And when we jumped 0 volts to those two grounds, our voltmeter would then show a voltage that changed when we stepped on the throttle. And it changed normally, like it should. So that means our pedal assembly is good. I would have liked to have shown you this stuff in real time, like underneath the dash, but we are crawling around, standing on our head underneath there, and it's very difficult in a tight area. You can barely get to the connectors. You're worried that you're going to short the connectors together. But this testing is pretty conclusive that our throttle is good. So as we had this ground wire jumped to ground on both of these, we once again looked at group 62 and there was no change. So at that point, we have to wonder, number one, why is there 5 volts on the ground? And why is there no change when our throttle is working? So then we ask ourselves, why is there 5 volts on our ground? Maybe it's shorted together with our reference voltage here inside the harness somewhere. And I really need to point out that both of these grounds, you follow them up, they do not go to the battery, they do not go to the engine block, they do not go to an eyelid on the body of the car. Both of them go to the computer. Now, why would a ground go through the computer, you ask? Well, it's all for self-diagnostic purposes, so that the computer can see a problem with that throttle. Okay, understand that our throttle sensor is 2 3-wire sensors. So on each one we have power, ground, and signal return. But there are 2 of them. But what you need to understand is that these sensors are in one assembly, and all of the wires from it go into the engine computer. So the engine computer obviously is provided 12 volts from the battery, and somewhere inside there is a regulator that regulates this voltage down to 5 volts to go there, and it also comes down to the other 5 volts also. But in order for these to go to ground, somewhere inside this computer, these have to join together and then come out of the computer to a real ground. So what does this mean to our circuit? Well, it doesn't mean much unless you take into account our oxygen sensor. Now, so here is an OEM schematic of our oxygen sensors. This one is actually an air-fuel ratio sensor or wideband O2 sensor. So it's got extra wires. But this one, which is our rear O2, shows very clearly a heater and the sensor portion of it. And notice that both wires from the sensor portion of it goes to the J220, which is the engine computer. This is the ground right here. When the computer wants the heater to come on, it puts 12 volts. Understand that 12 volts comes from the computer on this circuit, and it's provided ground by this branch right here. So the O2 sensor has a signal return and a ground. The signal return on a standard oxygen sensor, the O2 sensor, is just a generator. It actually makes voltage. Now sometimes there'll be like a reference voltage on this circuit, but the oxygen sensor makes voltage that floats on top of that reference circuit. But here's the point. If at any point this 12 volts goes to here, what happens inside the computer? Let me draw this out. So here's our previous drawing. 6 wires on the throttle sensor. Both grounds going to ground here. Understand that our O2 sensor right here has 12 volts to the heater going to the computer, and then it's provided a ground somewhere else, it doesn't matter where. And then the signal return wire comes to the computer, and then the ground also goes to the computer. Where do you think that ground hooks to? it probably hooks somewhere in here. Now obviously there could be there's circuitry in here. It might go through a transistor, it might just go through like circuit board traces, but what happens when this 12 volts, when they want the heater to come on, goes to right there? There is no resistance, like there's resistance in the heating circuit right there, but there's no resistance, so too much amperage flows through. What happens when too much amperage goes through a fuse? The fuse melts and burns away. What happens when too much amperage goes through the circuit board inside here? It melts and goes away. It burns away. What happens if there's transistors or integrated circuits in there? They melt, they burn up, they go away. So when these wires get shorted together, it could even be this wire for all I know, it doesn't really matter. But what happens is this burns out, and so this is no longer providing a ground to this circuit, or this circuit. So when we check here, since they don't have a ground, how can we confirm that? By looking at our oxygen sensor. I'm going to go back to the other schematic. By looking at our oxygen sensor and see if the ground part of the oxygen sensor is at 5 volts also. Now we have a mass airflow sensor code also. Almost for sure one of these wires is a ground as well. I'll probably have to get the OEM schematic, because OEM schematic has stuff written in here to tell which wire is which. Be nice if they did on these schematics as well, but they don't. If one of these is supposed to be at ground and it's at 5 volts as well, then we can say that this mass airflow sensor code is going to go away when we do this repair. So the theory would have to be at this point that our damage to the O2 sensor wires has shorted 12 volts directly to ground. The weakest point in the system was something inside the computer, either a circuit board trace or a transistor, and now the computer is not capable of providing a ground to this, or this, and maybe even the ground for the mass airflow sensor. So we're going to make some checks at the mass airflow sensor and at the oxygen sensor to see if their grounds are at 5 volts. We might assume that our wires here, our ground wires on the sensor, might be shorted to the reference wires right here. So let's say there's a short here instead. I don't believe that that is even a possibility, because the ground would be drawing that 5 volts to 0, and we would have 0 volts here and 0 volts here, and maybe it would fry out our regulator up in the computer that I kind of drew. Let's just call that a 5 volt regulator right there. So I don't really buy that that can be the case. So let's go back to the car, measure the ground on the O2 sensor, and measure the ground on the mass airflow sensor, and see if they're at 5 volts also. Okay, as I'm working on this here Jetta, I'm trying to get the hood open, and I've spent a significant amount of time taking this stuff in there apart trying to find this thing, and I'm sure I spent a half hour, if not more. And so I just called the customer to ask how to open the hood, and here's what he told me. He said if I pull back the trim here, I'll find the cable. Guess I'm going to have to open the door. Pull back the trim, I'll find the cable, and I can pop the hood. Now, to the customer, that's just a simple oversight. Oh, I'm sorry, I forgot to tell you. But to me, that's a half hour's wasted time. Please, people, come on. Okay, we are under our 1.8T car with the throttle problem. So now I've back probed the gray with a white wire, and I have 4.9 volts. That was what I was expecting, because I'm assuming the engine computer is not capable of providing that sensor with a ground in the same way that the computer It's not capable of giving the throttle sensor a ground. So we're going to check the mass airflow sensor as well. Okay, there's 4 wires there. Should I assume the black one's the ground? Let's check it and see. We'll just touch it. 4.9. I have a slight discrepancy on my OEM schematic. The OEM schematic doesn't show a black wire at all. It doesn't show this combination of wires, but my color schematic does. It shows this exact color combination. But I want to point out that the black wire, I'll go ahead and front probe, I can just touch it. It shows 5 volts on the black wire, 5 volts on this red wire. This wire I would assume is the signal return. It shows nothing. And then this last wire shows basically nothing also. Based on the schematic, this should have 12 volts on it. Okay, I decided to pull the computer out to see if we can see anything visual inside that is fried from the 12 volts going straight to ground through the computer. What I'm seeing is that's paint marked. Somebody's been here already. Somebody's taken that apart and squeezed it back together with a pair of pliers, because there's plier marks on both sides of it. And there also. So I don't know when they did this, but I'm taking it apart too. Okay, I have the computer apart and I've taken a real close look at it with a flashlight and a magnifying glass, and I'm not seeing anything visually wrong. I don't think that changes anything. I'm still fairly convinced that this is going to need a computer. Okay, some of you that watch my channel regularly might recognize this computer. It came off another car that we did a video on that had a bad computer, and it wouldn't fire the number 2 coil. As you can read on there, let me flip this upside down. 1.8T 2001, won't fire number 2 coil. So the benefits you get when you come to a Volkswagen specialty shop is we can swap in a computer and see if it corrects our problem. Now, this car is a 2004 and this computer came out of 2001. I'm not 100% sure it would run this motor. And a matter of fact, right now I know it won't, because this car has an immobilizer, and the immobilizer is very active since I've plugged in this computer. But what I can say is that when I plug in this computer and I go to this mass airflow sensor connector, I'm going to just back probe it here. I no longer have 4 volts on the ground. I am pretty sure I can call this a ground. Now I'm going to do nothing but unplug that computer and plug in the original computer again. Okay, I've done nothing else but plug in the original computer, turn the key on, and I now have 4 volts on the mass airflow sensor. Now I could delete this immobilizer real quick. Wouldn't take that long. Plug it in, fire up the car. Obviously I'd have a misfire on the number 2. But I could rev the throttle and probably tell whether this is correcting our problem or not. I don't know if that's necessary. I might take that extra step just for the video's sake, but the reason why is because I have called the customer, and based on the condition of the car and the cost of replacing this computer, the cost of putting 2 oxygen sensors on it, and the potential problems that it might still have, which obviously it still has a problem there and a problem there, and I'm not sure they're going to fix it. They're trying to make a decision, so maybe it'll be fun to see if I can delete this immobilizer, make this car run, make the throttle work before the customer comes and gets the car if they choose not to fix it. Okay, I've plugged in, deleted the immobilizer, and I'm not 100% sure this computer is exactly the same. I'm not even sure it's going to run the car, but I know if it does run the car, it's going to have a misfire on the number 2. But let's start it up, see if it'll run the car, and see if the throttle now works. By the way, I left the oxygen sensors unplugged because I don't want to fry with this computer also. But if it does fry this computer, it doesn't matter much because it already has a misfire on number 2. Well, it does start and run the car. And let's take a look at that throttle down there. I'd say that's pretty conclusive. So I think whether the customer fixes it or not, we're going to end the video here. If you appreciate that we spent the time to share this information, click like and subscribe, and consider financially donating to the continued production of these videos by finding the donate icon on my website at www.kansascitytdi.com.